Wow, so excited you're watching this video today. I have a question on the board that a student asked me. He said, how do you find the LCM of terms like this? Meaning when you have algebraic terms like this, meaning when you have digits combined with letters, or a digit and a letter, and then you also have another term, and maybe probably another term, or you have just two terms and you are asked to look for the LCM. So he asked me, how do I find the LCM of this question? I want to show you how to get the LCM of this question without much stress. Very simple. We're going to be using a tabular form so as to make it very simple for us. Now look at this. We have the question. The first term here is 8x y squared. Now I'm going to use a tabular form, just like I said. We'll solve it in a tabular way. So I have the first term, so I will have it here written here. The next one is 12x squared y, and then the next one is 24x cubed y. Now this is what I'll have, and you rule this. Now what you do is this: since you have letters here, and letters here. Now what you are going to check is, don't bother yourself, just look for a letter that any letter that is here or this place can be here or should be here. Now when you start from the list, the list based on the ranking of the alphabet, x comes before y, x comes before y, x comes before y. So what is that letter that we can use to cancel any letter out here? We start with x. X will cancel the x here. We'll have this 8 and y squared. This x will cancel 1x here. What we'll have is 12x and y. This x will cancel 1x here, since it's x cubed, so 3x here. Don't forget 2x, so x cubed, x squared rather, and here is x cubed. So this x cancel 1x here. We have x squared, and then we have y. The next thing is, we still have, if you discover we don't have x here, but we have x here, we have x here, so we are permitted to use it, because what we're looking for is not here. So we will still use the same x until the x are no more here. So there's no x here, so I'll repeat this. It means it cannot be divided by x. It can divide this term, so I have 12 repeated. I have y, because this x cancel this x. Now when I come over here, I'll have 24. This x will cancel 1x here, so I have x left and y. I'm not done. I don't have x here, I don't have x here, but I have x here, so I'll still use x. So x goes here. Since it does not occur here, I repeat this. It doesn't appear here. I repeat this. Since it appears here, I have 24. And then what? This x will cancel this x. So what is left here is just y. The letters there. Then the next thing you see, we are done with all the x. So we go to y. So we have y here. Y goes here. We have x 8y. So this y will cancel 1y here. We have 8y left. Y will cancel y here. What you have is 12. Y cancels the y here. What you have is 24. Now, but if you discover we are not still done, we still have y left, so I'll still use y. Y cancels this. I have only 8. I have 12 left. I have 24, because there's no y here, there's no y here. Now the next thing you do is to go ahead and begin to use numbers. I have 8, 12, 24. So what number can divide any of this? Let's use 2. 2 into 8 is 4. 2 into 12 is 6. 2 into 24 is 12. Mind you, you can just go ahead and use 8 here, or use 12 here, or use 24 here, because what you're looking for is a term that can divide either 8, 12, or 24, or a term that can divide all of them. Hope you understood that. Now, so I'm just using 2, because most preferably you go with the least factor, the factor that can divide any of this term or all of them. So I've used 2. The next one, 2 can still divide any of this, so I use 2. 2 here is 2. 2 into 6 is 3. 2 into 12 is 6. Then the next one, let's continue here. I can still use 2, because I have the least term here is 2. So 2 divides is 2. What I have is 1. 2 divide this. 2 cannot divide this exactly without a remainder, so I repeat the 3s, because 2 cannot divide 3 exactly without a remainder. So the next one, 2 into 6 is 3. Now, if you discover, or I have 1 here, so I don't need to bother on what will divide this. So what can divide either this 3 or this 3? Anyone. So use 3. I'll have 1 here, I have 1 here. If you like, repeat this one. So what you have left is LCM, is to calculate the LCM. So the LCM is x times x times x. So I have x times x times x times y times y, y times y, times 2 times 2 times 2, 2 times 2 times 2. And the next one is times 3. So we have LCM, therefore, is equals to x times x times x is x cubed, because 1, 2, 3. So we have x raised to the power of 3, x raised to the power of 3 times y times y is just y squared, because you have 2 y's here, times 2 times 2 times 2. That's 2 times 2, 4, 4 times 2 is 8. 8 times 3 give you 24. So we have LCM equals to write this 24 first, x cubed times y squared times 24. So we have 24 first, then follow this order, x cubed and y squared. So this is the LCM of these terms given here. Thank you for watching. Don't forget to like, to share, and to subscribe for more videos. And in case you have a question or you have any comments, feel free to send the comments across to us.